Thanks, Anton, and thanks for setting the groundwork for what we are talking about today. So as discussed, really what I want to spend some time on is more the overview of what the code is about rather than going into detail on the code. We're going to spend quite a bit of time over the next few months trying to interrogate the details behind the code. So if we go back to the model, and many of you would have seen this many times over, but the picture is just trying to show what the transmission system operator's responsibilities are in terms of the marketplace. So obviously, if we take the dotted line is the TSO, the four businesses that Sekomochi was talking about earlier, obviously the network operator and the system operator, still similar to what has been done for many, many years, obviously changes as we go into the market with more players, more people involved in the market, and their responsibility shifts quite a bit. But the two new entities that are introduced both by the ERA Amendment Bill and talked about in the code is the market operator and the central purchasing agency. The market operator is really about creating platforms for others to trade. It's not a trader, it's not buying and selling. It's just establishing platforms that make it easier and facilitate the trade that is taking place. The idea here is that we focus on the physical energy components. So it's day-ahead energy, intraday markets, and balancing form part of the responsibility of the market operator, as well as day-ahead reserves, that we are forward planning and scheduling those reserves on a day-ahead basis to ensure that the system operator in real time has the capability to keep the system in balance. And I think Hans was talking about it earlier. There's a big question like, why do we need a day-ahead market? And it really is about that forward planning, that if you don't have a day-ahead market, particularly in an environment where we still have a huge amount of thermal generation, that you need to be able to plan in ahead. You don't have huge luxury of time in order to be able to pick up big thermal plant if there's a shortage. So you plan and you make sure that there are rules that bind everyone to the day-ahead market. And that's where we come up with the concept of a balanced responsible party, that people are trading, they get an outcome from the day-ahead market, there's a commitment, either a schedule to buy or to generate, and then you need to make sure you deliver that. If you're out, which is bound to happen, that's just the reality of the real world, you have an option under the intraday to get yourself back into balance, or then you're exposed to balancing where the system operator has got you back into balance. So those are just kind of those platforms where we focus on physical delivery. And I'll speak a little bit more about how the interplay between those three work, at least in the proposal that we've put together. The central purchasing agency is quite an interesting one, and I think Hans has laid the foundation quite nicely to talk about the special purpose vehicle, because that's essentially what the central purchasing agency is. It's not a trader. It's not going out there to buy and sell for profit. It's creating the mechanisms for us to manage the transition to a competitive market environment. So there are three very key roles that we still see for the central purchasing agency in this transition. The first one is being the legacy buyer for the Section 34 IPPs. All the existing contracts are not going to change when we go into the market. The existing contracts with the Section 34 IPPs remain the same, and the central purchasing agency will continue to buy from those generators and effectively then sell that energy on into the market operator. But because it's buying and selling, it doesn't mean it necessarily becomes a trader. It's just almost passing that information on and dealing with the pricing difference. The Section 34 IPPs, obviously, they've got contract prices that are set, that are not going to change, but the market price is going to change all the time. So the central purchasing agency acts as the buffer between those two. And where there's a differential, particularly when there's a negative differential, it has to be able to pass that cost on to consumers in the market, and we can talk about the wholesale tariff, but there still should be some sort of legacy charge. So the central purchasing agency is cleared of all the sort of imbalances that will happen from one day to the next. The second role is about this transition, and I will talk a little bit more about the transition mechanisms, but the idea is these vesting contracts where the central purchasing agency has hedging agreements upstream with, at this stage, sort of thinking just the Eskom generators, they have a vesting contract for the transition period, and then downstream to distributors. In the ERA Amendment Bill, it describes that vesting contracts will only be with distributors. So the Eskom distribution, municipalities, anyone who's participating in the market would have a vesting contract at a wholesale tariff that keeps the two in balance. And that is the part of the transition mechanism. Every year, we might expect to reduce the volumes associated with those hedging agreements so that consumers and generators become more exposed to the market every year. And it's a progressive process through the transition. The third is really around capacity, trying to manage as we're going through this transition, ensuring that there is the dispatchable capacity that Hans was talking about. I mean, and this is kind of more sort of a kind of where we're seeing where the market's going right now. Most consumers are looking to buy renewable generation. It's the cheapest form of generation, energy only. You're going to get good prices for a renewable plant, but the problem is the system needs something else. The system needs the backup, needs the capability to ensure that day by day the system is in balance. And we need to find ways to make sure that that is happening. It could well be that the market, because of pricing mechanisms and price differences taking place in the market, that consumers are doing that anyway, because they want to ensure that they've built batteries or gas backup or all those good things to manage their risks. And then it's happening. But if it's not happening, the Central Purchasing Agency needs to have the ability, one, to do indicative kind of planning, looking into the future, as we do with the medium-term security analysis we do every year, looking 5 years out, what does the system look like, getting a sense of what is required in order to keep the system in balance, and then having the ability to go to the market and with some sort of capacity contract to ensure that people are building the backup that we would need in the system. That will hopefully migrate across to a capacity market, not the Central Purchasing Agency making the decision, but actually establishing a trading mechanism for capacity 3 to 5 years out. And that's the ideal, and that's something we kind of want to work on, maybe in this process of reforming the code, building in a capacity trading process. But at this stage, it's still kind of designed that the CPA is focusing on that in the short term, and hopefully we can then migrate that across to a more sort of competitive mechanism. The big thing here is also that why it's called a multi-market model is that it allows for physical bilateral contracting, that it's not a centralized dispatch process. Consumers, large power users, municipalities can go out and procure on a long-term basis for physical delivery of energy. Okay, and there are obviously pros and cons to the whole approach, and one of the things we have seen is that, and I know Alex can probably talk about it as well, is that one of the problems of trying to do a PPA over 20 years between buyers and sellers is the physical risks over that 20-year period, trying to deal with what happens if the network can't take the energy, what happens if there's load shedding, you've got to deal with all those risks in a PPA. If you turn that and you allow that the market deals with the physical risks, the market takes care of constrained generation, the market takes care of load shedding, then you can actually just do a financial contract between the two parties. Yes, it's an ideal. But the thing is, the idea here is that the multi-market model allows for people to continue with physical bilaterals, particularly because people are doing them now. And you want that to continue. We're not trying to circumvent processes that are already in place. People have gone through the stress and the pain of doing the PPAs. We're not overriding that at all. So those would continue into the future. But one of the obligations that is there is for people in physical bilaterals, by default, will be what we call balanced responsible parties. And the idea of the balanced responsible party, whether it's the generator or the consumer or both, have to declare to the market operator every day ahead, what they are going to generate or consume on the following day. And then they are held accountable to that, because they would be part of a party to the balancing agreement, so that when they have actually consumed or generated something different, the balancing mechanism will kick in. And in that way, you then bring everyone back together again. So I know Hans raised the question of, would we have multiple market operators? You can absolutely, on a day ahead, and maybe to some extent on an intraday, have other platforms where people are trading with one another. You're going to have traders who are actively doing that between their consumers and generators. You can have platforms that allow for that, but the information needs to come through to the market operator for balancing, because the market operator is taking care of the balancing on behalf of the system operator. And that's quite an important aspect of this, that everything comes back to making sure the physical delivery is managed in the process. So when we talk about the market code, again, it's a very high level kind of simplified version of what the code is really about. we're focusing on establishing who has certain roles and responsibilities. And here we include, obviously, NERSA. What role does NERSA have? What role does the system operator have, the market operator, and the various participants? And here we have two kind of almost levels of participation. The principal level is the balanced responsible parties. Everybody that is generating or consuming has to be a balanced responsible party unless they're going through a balanced responsible party, because somebody has to take care of what is declared day ahead and what is actually delivered. Then you have another level, which is the market participants. And the market participants are the people who are actively trading in the day ahead or the intraday market. And therefore, they have different rules and obligations because they're submitting information as part of the trading platforms. And that really covers those sort of responsibilities. We do also, without going into too much detail, we talk about obviously a market code advisory committee, which is a little bit like the grid code advisory committee, which takes care of market code changes. These changes need to be, we need to allow that the code has to change over time. It has to reform itself. The question was asked earlier about technologies and how technologies play in the code. We are technology agnostic, but as new technologies come along, they might bring in a lot of the code into question about how we deal with certain things. As an example, and we can get to that later, we're still thinking of doing like a single price across the whole of South Africa. We're not talking about price areas. We have constrained generation management to deal with, if there is a constraint between supply and demand in certain areas. But the moment you bring in batteries and other sort of more flexible generation, they can game the system when you have those sort of counter trades taking place. And you have to then look at, well, is that really the ultimate kind of plan if you're going to have the ability of new technologies actually undermining and having these adverse consequences that we hadn't planned for in that. So it is definitely, we always have to have the code being modified over time to ensure that we can deal with changes in technology, but also picking up where there were these inadvertent consequences that we hadn't sort of planned on. Then obviously there's a process. So we talk about the market code changes. We talk about how we add on new customers, new members of the market. How do they become market participants? How do we deal with issues if we have to, because we're talking about credit cover, if a customer or a participant defaults, what happens to that participant around the default, suspension, all those kind of things have to be built into the code, and they are there at the moment. We talk about the products, and I'll spend some time on that shortly. What are the different products that are on the market or the platforms, as well as then the timelines for payment, for settlement, and all those issues. So in the products, as I mentioned, we do talk about predominantly day ahead, intraday, day ahead energy and reserves, the intraday energy auctions, the balancing market. The capacity market is something that we still need to spend some time on and working on different options to ensure that we can correctly trade for capacity into the future. Ancillary services, as well as kind of the other services, which aren't really covered massively in the code, but will occur as a result as we go into the market. So when we talk about the day ahead market, someone actually asked the question, and we haven't really dealt with a lot of the Q&A, but on the chat, someone was asking the question about marginal pricing, how we have a market clearing mechanism at marginal price. The most expensive generator that is actually scheduled sets the price for everybody. It's quite an important discussion for everyone to understand. It is not immediately intuitive. It's an economic principle that really ensures that we have an efficient outcome. If you did pay as bid, if all of the generators, and here I've got a sort of set of generators that are kind of going from cheapest to most expensive in terms of the supply curve, if you were paying each what they had bid, but there's then an average price that everybody's paying, there will be some generators down here who are getting a very low price for exactly the same product that someone up here is delivering. And there is then a tendency to try and game the system. Because this is an auction, it's a repeated auction that takes place every day, they would then see what the results are and saying, oh, hang on, why am I getting paid 300 Rand a megawatt hour when the price could be 1,500 Rand a megawatt hour? I'm going to bid 1,500 Rand a megawatt hour tomorrow. And then you get a little bit of manipulation taking place. And then that leads to an inefficient outcome. The principle of day ahead kind of scheduling or the scheduling mechanism is that you need to run on short-run marginal cost. And then you have to incentivize that participants are providing the short-run marginal cost. So if everyone gives you their true information, then you know that your outcome is more likely to be correct because you're scheduling on that basis. If you don't have that mechanism in place, you have to second guess. And if the cheapest generator is bidding ludicrously high prices and now you don't schedule them, that's a deeply inefficient outcome. So it is a strange concept, but it's true, tried and tested. It's used pretty much in all markets around the world, at least where we have these repeated auctions. So that the most expensive generator would set the price for all. One of the things we try to build into this code, and it's quite an important one, is around demand response, that the demand side needs to be able to influence the price. If we think about, and we do it now internally within Eskom, so this is quite a surprise for everyone that we run these processes internally, but the demand side is just an inflexible forecast. We just know, someone's forecasting what the consumption is going to be, that is what you schedule to. But if you have demand response built into that, then you would see that customers start giving you their preferences. If the price is going over 1,000 Rand a megawatt hour, I'm going to back off. I have the ability to consume less, so I'm going to move and allow myself to actually influence the price, which means that the moment you start building that in, you get a more optimal outcome because you will now schedule at a lower price because you've built in this demand response. So instead of scheduling at the highest price possible, you can actually now schedule at a cheaper price, even if it is a lower production and consumption point. It's more efficient for everyone. And Hans mentioned this concept of producer surplus and consumer surplus. So all the producers below this level, they have producer surplus. They are getting a price better than what their costs are. So yes, they pocket a nice surplus there. But the consumers are also getting consumer surplus. So these customers were willing to take a higher price. And now they're actually paying a lower price, they get consumer surplus. And the whole idea is that you get an efficient outcome by allowing that to happen. One of the things that, as I mentioned, is that when we talk about network constraints in the environment that we're in now, we don't have a huge amount of them, but we're about to go into an environment where that's going to grow. And now you have to have a very good way of dealing with constraint generation. And that means we do what we call an unconstrained schedule. So it's the schedule that looks at just the market outcome, supply and demand. We have technical parameters. Sorry, I didn't talk about that. Our difference of why we are not exactly the European model is that we allow for technical parameters to come into the scheduling process. So you have minimum up and down times for a thermal plant. You have ramping rates, all those kind of technical issues that influence what the more technical likely outcome will be, you build into the scheduling process. And when that means that the outcome comes out, at least at a generator level, you're going to be able to produce that on the following day. But now you bring in the network constraints. Now there's another level of constraints that get brought in, and that we then run a constraint schedule, and you can see the difference, which is caused by that imbalance. And so the proposal as it stands now is that the generators that are forced to back off because of the constraint get paid out for the loss of profit that they are now experiencing. They would have been profitable in the unconstrained. They are now not profitable. You basically have to pay them out. Similarly, the generators that are producing more because you're keeping the system in balance, you pay them their incremental cost. So there's a cost on both sides. It kind of needs to be borne by the system operator, and we see that as an ancillary service. It becomes constraint generation, which they have to absorb and pass on to all consumers through the ancillary services mechanism. So that's constraint, dealing with the physical risks of the network constraint, and it's managed in the day-ahead market. We also co-optimize with reserves. So this is an energy picture. We also have a mechanism where the system operator is saying, I need a certain amount of different reserve categories. So there's instantaneous reserve, regulating reserve, 10-minute reserve, and we schedule that, and we try and co-optimize around the costs so that the outcome is the cheapest energy price, but also making sure we meet the reserve requirements. And that's kind of also part of the process of the way we do it. In Europe, and Hans can correct me if I'm wrong, the way I understand it, often you have discrete markets that people can choose to be either in the energy market or in the reserve market. We're saying there's no choice here. You can say, I would rather be in the energy market or I'd rather be in the reserve market, but it's still going to be co-optimized by the system as to which is more optimal for everybody. and how you build that into the scheduling tool is part of the market code. So here, when we look at how we deal with intraday, so at the end of the day ahead market, you would have had the information from the physical bilateral generators. And sorry, it's quite a busy kind of depiction, but we have the generators on the left here. Making sure I'm pushing the right button and I don't, yep. So we've got the generators from the cheapest to the most expensive, and I've just kind of chosen some random kind of generation there. And then we have large power users, retailers, and some of the power users have their own generation capability, and some obviously then have demand response. So the idea then is that when we optimize, we've got a schedule for each one of those entities for an hour. And some will have decided through physical bilaterals what their positions are, and they tell us. So now we know what that position is at the end of the day ahead market. But the reality is that things change. So you might find that in a power station, one generator is tripped, at least they have another one that maybe backs it up, and then their net position is zero. But you might have others where they are actually asked to pick up because there's additional generation required by a consumer that actually knows it suddenly has to consume more, or a retailer that has to supply more the following day. And the whole idea of the intraday, is the way we've kind of proposed it, is that you have regular auctions. So during the day, people are shifting their positions. The only thing we allow you to shift is availability. We don't want the prices to shift. The prices from the day ahead automatically come through to the intraday. But availabilities or forecasts can change. So a generator can reduce their availability or potentially increase if there's been an outage that has been postponed. A consumer can shift what they expect to consume, either upwards or downwards. And then we take that together and we do an auction every 6 hours and then give a result. And there's a pricing result of that, because obviously if we now suddenly have to consume a lot more, the net generation is higher than what it was the day ahead, there has to be a new price for all the people that kind of caused that. If it's lower, we actually just leave it at the S&P. We don't allow the markets to drop, the price to drop. It actually stays at the S&P. So if there's somehow more energy available on the following day, it still just gets settled at the S&P. Then the fun starts when we now go into the balancing mechanism. And similarly, we keep all of these three markets moving sort of along the same trajectory. The information that's used for the day ahead goes into the intraday, goes into the balancing. So there's no opportunity for people to try and game the system by putting in new bids and offers into the balancing mechanism. Whatever you've declared day ahead must still go through to the balancing. And obviously, if things have changed, that would lead to an outcome in the balancing mechanism. Again, we don't have a huge amount of time to go into the detail of the balancing, but one of the important things about balancing is that you have to ensure that, one, there is some incentive out of the balancing mechanism for people to be as honest as possible on the day ahead, to give you the information, the best information they have on at time. But you also don't want to be too punitive that now people start behaving almost perversely. One, withholding capacity from the day ahead because they're worried that they might need it for balancing. Or two, building huge amount of backup capacity, gas, batteries, whatever, just to avoid balancing. That in itself becomes actually defeating the point of an efficient outcome. So the balancing mechanism, we still, and Graham and Mike will remember this from 20 years ago, still pretty much the same principle, weighted average. We just kind of look at what would the system operator have been able to call up each of the increments, and then you do a weighted average of those increments and pass it on, rather than go to the marginal generator and everyone pays the marginal cost. So that's one of the few times that we move from the marginal cost kind of mechanism. We just use a weighted average, and that's kind of still the same principle that is sort of was originally proposed quite some time ago. The important thing there is that we also have an upward and downward price. So the up price is for when we need additional generation on the system, and a downward price when we needed to back off because there was now more capacity available or more energy than what was required. But you actually set a price in both directions. It doesn't have to be that way. You could do it, and a lot of Europe does it, where there's one price which either goes in the up direction or the down direction. Our preference is that you still want to create the incentive for the best information on the day ahead. So by going in one direction or the other, you may find a lot of consumers or generators sailing with the wind. They don't give you the best information, but they just happen to luckily in that hour be on the right side of the market. It becomes a bit of a problem. So we try and make sure that we go in both directions. At least that's the proposal. Okay, I'm running out of time, so let's just to focus on the transition. So we have spoken about this concept of a vesting contract. So the central purchasing agency would have vesting contracts upstream with each of the Eskom generators at this stage. As I said, in the ERA amendment bill, vesting contracts are defined in a very certain way. So we would probably stick with that. But the idea is that you have these upstream generator contracts, and then downstream you have a sort of wholesale tariff that applies to distributors, and the volumes are hedged at 100% on day one when the market opens, and then decrease by 20% every year. And then those generators and distributors, retailers, get more and more exposed to the market. What happens then is that they can then start doing CFDs with one another, so that the hedging mechanism takes place outside the central purchasing agency's vesting contracts. So it's not as though everybody has to be unhedged. They're still allowed to hedge. They just hedge with one another directly, either through a derivative kind of platform, which maybe the JSE sets up or someone, or over-the-counter kind of trades for that sort of hedging. Okay, you might notice that the date I put there, of course, there's no guarantee around that date. We're sort of looking at what would be a feasible date if the ERA amendment bill is passed in the next month or so, and we are working on the market code. At an absolute push, maybe you could start the market in April 2025. But I think, as we discussed earlier, there are still a lot of things to be done. It's not really about the market rules. It's more about getting everyone ready for this big event. It's like training, making sure that the banking systems are in place, because a lot of this stuff will have to involve information between the banks and the market operator, getting those platforms up and ready and making sure we've tested them and make them ready for cybersecurity and all those good things. There's a lot we would have to still do. The probability of being there ready by April 25 is not strong. I wouldn't, but again, there might be pressure for us to do that. But I still think the more realistic one is to aim for April 2026. But the idea is then you have 5 years during which the vesting contracts unwind and give people more exposure to the market prices. It does mean that on that day, there might be participants who are not subject to vesting contracts. Those participants can come in, generators, traders, consumers could theoretically jump into the market, jump into the deep end and participate in that market. We have to see, what does that mean for the transition when you have almost like two-tier participation going on in the market. Yeah, I'm not going to go into this too much detail. I think Anton's already discussed it, but a lot of the work that was done for this actually started in Eskom back in 1996. January 1996 was when kind of the internal power pool was started in the reserve markets, 2001, Mike, if I remember correctly. And then the multi-market consortium, 2002, 2003, was a government appointed consortium that looked at the market code. And some of us were kind of seconded to work on that work then. So yeah, this is all, a lot of it is not new, but what has happened in the transition has been for things like the grid code, because the grid code didn't exist in those days. The grid code establishes and makes it easier for us to establish a market because the technical issues are managed under the grid code, and it really deals with a lot of the foundational stuff that is needed for the market to work. We also then have the third-party access, the wheeling, as most people have been involved in a lot of the wheeling activity. That started in 2008 and also establishes kind of a lot of the principles that we can then talk about, how we deal with use of system and network charges and make that different to energy over time. So yeah, so this, as Anton says, is not in a vacuum. It has been worked on over many, many years. I think that's it from my side. Thanks.